Okay, students, welcome to the homework help video, page 172. Let's go ahead and get started. Let's take a look at numbers 4 through 7. The directions say to find, to use these two given figures here. And also in the directions they state this. They tell us that triangle ABC is congruent to triangle DEF. Okay, so with that in mind, angle A right here is congruent to angle D, so A is congruent to D. B would be congruent to E, so B gets 2 slashes, E gets 2 slashes. And then C is congruent to F, so 1, 2, 3, 1, 2, 3. Okay? And with that in mind, here we go. This should be pretty simple. So here we go. What is the measure of angle D? Well, D lines up with A, so 105 degrees. Number 5, what is the measure of angle B? Well, here's angle B. B has 2 slashes. And angle E has 2 slashes, so 35 degrees. Now I think what they want us to do from here is they want us to go ahead and add these together, subtract from 180. So angle B is 35. So 105 plus 35 would be what? 140. So this has to be 40 degrees over here to give us a total of 180. And so this is 105 here. 1 slash, 1 slash, this is 40. So this is 40 right here. So we can finish this pretty quickly. What is the measure of angle C? 40 degrees. What is the measure of angle F? 40 degrees, okay? All right, moving on to numbers 8 through 10. True or false, a right triangle can have an obtuse angle. Let's think about that for a second, guys. If here's a right triangle, is 90, okay? And obtuse means it's bigger than 90. So can one of these angles over here be bigger than 90, for example? Let's just pretend, even though it doesn't look like it, let's pretend this angle here is 91 degrees, okay? Well, that's impossible because 91 plus 90 is 181, and the most that any of your three angles can be is 180. We haven't even yet figured in the third angle down here yet, so no, that's false. A right triangle will always have two acute angles, always, okay? Always. Okay, number 9. A triangle has two 60-degree, a triangle that has two 60-degree angles must be equiangular. Well, yes, that's true. Definitely think about it, guys. If this triangle here has 60 degrees here and 60 degrees here, what does the third angle here have to be? Well, it has to be 60 to give you 180 degrees. So yes, if two angles are 60, then you definitely have an equiangular triangle. Yes, true. If a right triangle has two congruent angles, then it must have 45-degree angles. Well, let's see. Let's think about that. Here's my right triangle. This is 90 degrees. Now, I know that these two angles here, we'll call it angle 1 and angle 2. We know they have to add up to 90 because this angle here is 90. So the measure of angle 1 plus the measure of angle 2 has to be 90 because 90 plus 90 is 180. Now, if these two angles are going to be congruent, which is what it says right here, if a right triangle has two congruent angles, then it must have two 45-degree angles. That's definitely true because 45 plus 45 equals 90. So yes, that is definitely true. Okay, definitely. All right. Okay, moving on to number 11 and 12. I'm not going to ask you to. I'm not going to measure these for you on paper on the computer here, but I will say this to you: on a test or a quiz, make sure you know how to use a protractor. Okay, students, please. And you say, well, Mr. Earhart, how in the world was I supposed to measure these? They're in my book. I would encourage you to take a sheet of paper, okay? For numbers 11, 12, 13, and 14, take a sheet of paper. Pick up the sheet of paper and put it over the triangle in your book, and then trace the triangle onto your sheet of paper and then measure the angles doing that, okay? But yes, you were to do this, and And so quickly, here's the answer. Number 11 was, let's see, you were supposed to measure the angles and then classify it according to its angles. Okay, so this triangle here was supposed to have a 35-degree angle, a 55-degree angle, and a 90-degree angle. Okay, so this triangle here was a right triangle. Okay, if you measured the angles at number 12 correctly, you're supposed to get this: 35 for one angle, 45 for another. I mean, all of this is approximately, I mean, if you're making, if you're off by a couple of degrees here or there, that's totally fine, okay? And 100 degrees, so this triangle here would be obtuse because you have one angle larger than 90, okay? All right, numbers 13 and 14. For 13, you were supposed to get 60, 60, and 60, so this would be an equiangular triangle. I'm not going to write that out, but equiangular. Okay, number 14, you were supposed to get 50 degrees, 65 degrees, and 65 degrees. So all the angles are acute. So this would be an acute triangle, okay? All right, moving on, not too difficult, okay? All right, number 9. Oh, these are a lot of fun. Here we go. Okay. We're supposed to find the measure of all the labeled angles. So here we go. All right. Well, this is green, shows up pretty well. I'm going to use green here. This is 90. 90 plus 60 is 150, so this has to be 30 degrees here. So the measure of angle 1 is 30 degrees, okay? Now, this angle here and this angle here are vertical angles. Vertical angles are congruent. So angle 2 has to be 60 degrees, all right? And remember, students, I'm not necessarily going in order of angle 1, angle 2. I'm just going across the figure and just solving this as I go, okay? Now I notice I have a triangle right here. So the three interior angles have to add up to 180. So I have 60 here, 70, it's 130. So this has to be 50. So angle 4, angle 3 is 50. And let's see what else we have here. Let's jump over here real quick. Angle 8, look, I have a straight line here with the line coming off, so a linear pair. So this angle and this angle have to be supplementary. So if this is 55, angle 8 here has to be 125. So angle 8, 1, 2, 3, 4, 5, 6, 7, 8, 9. We'll put 8 over here. 8 equals 125. Okay. Now look, this is 90 right here, right? And I have a straight line here with a line coming off of it. So if this is 90 here, then angle 5 also has to be 90. So 5 equals 90 degrees. Now I've got a triangle here. Here's my three angles inside my triangle right here. So 90 plus 45 is 145. So angle 9 has to be 35. Because 35 plus 55 is 90, plus 90 is 180. So angle 9 is 35 degrees. Okay. Now let's see what else we know here. Okay. See this straight line right here? A straight line always equals 180. So this angle here, and this angle here, and this angle here all have to add up to 180 because they all make up a straight line here. So 70 plus 55 would be 125. So this has to be 55 degrees right here. So angle 6 is 55 degrees. And now I can find angle 4 pretty quickly. I've got three angles inside of a triangle here. 1, 2, 3. So 90 plus 55 is 145. So this would have to be 35 degrees. And then 7, this angle here and this angle here are a linear pair, straight line. Line coming off of this angle 7 would have to be 55 degrees. 55 degrees. Okay? All right, moving on to number 21. Number 21. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so here we go. 9 angles we're looking for, I believe. So this is 90, this is 30, 120, so this has to be 60, so 60 degrees. Let's see here. This is a straight, let's see, let's come over here. Okay, look at these two lines here. See that line right there? See that line right there? Vertical angles right here. So angle 2 has to be 130 degrees. Now students, look, here's a straight angle. Notice this angle here, this angle here, and this angle here make up that straight line. So this angle here plus this angle have to equal 180. So we have 30 plus 30 is 160, so this has to be 20 degrees right here. So angle 3 would be 20. Now notice I have a triangle over here. Here's my 3 angles inside of a triangle right here. So very quickly, this is 20, and this is 90. That's 110. So this would have to be 70. So angle 7 is 70 degrees. And while I'm over here, this is a straight line. A straight line always has up to 180. I've got 3 angles. 1, 2, 3. So 70 plus 20 is 90. So angle 8 right here has to be 90 degrees. Okay, moving on. Look at this straight line right there. Straight line. That means this angle here and this angle here and this angle here, angle 6, all have to add up to 180. We have a straight line right here. Okay, so 90 plus 70 is 160. Okay. So this has to be 20 degrees. Also, we could have done vertical angles. We could have said this angle here with this line here and this line here intersect. So this angle is 20. This angle has to be 20 also. Either way, you get the same answer. So angle 6 is 20 degrees. Now, let's look over here. See this line right here coming down right here? This line right here, we have vertical angles. This angle here, which is 30 degrees, and this angle here are congruent. They're vertical angles. So angle 4 has to be 30 degrees. Okay, now I know this angle's 30, this angle's 20. I've got 3 angles inside of a triangle, so 30 plus 20 is 50. So this angle here has to be 130, because 130 plus 30 plus 20 would give you 180 degrees. So angle 5 is 130. So we have one angle left to find. Here it is, angle number 9. Look at this. We have a straight line with a line coming off of it. Linear pair 130 and 9 linear pairs. So angle 9 would have to be 50 because they're supplementary. Okay, and there we go. Moving on to number 22. Okay, once again we have 9 angles. So here we go. Okay, let's see what we got here. Well, let's start with angle 5. Vertical angles, 2 lines intersecting, so angle 5 has to be 125 degrees. So 125 degrees for angle 5. Okay, angle 2 right here has to be supplementary. We have a straight line with a line coming off of it, linear pair. So we have angle 2 would have to be 30, 50, 55 degrees. So angle, what angle was that? That was angle number 2. Angle 2 is 55 degrees. And we're moving on. Here we go. How about angle 1? This is a straight line here with a line coming off of it. So angle 1 would have to be 125. Because this angle here and this angle here are a linear pair, thus they're supplementary, so angle 1 is going to be 125. And what else do we have? Let's see here. Okay, here's 50 right here. I have a straight line with a line coming off of it, so 50 degrees, and angle 6 have to be supplementary. So angle 6 would be 130 degrees. And then finally I have my first triangle right here. Here's my first triangle. Notice I know two angles on the inside. I know this angle is 130, and I know this angle is 25 right here. So let's see, 130 plus 155, that'd be 25 degrees. So angle 3 has to be 25 degrees. So that all three angles add up to 180. So this is 25. Now, I have vertical angles here. Look, two lines intersecting. So if this angle here is 130, then this angle here is 130. Then I've got a triangle right here. So 20 plus 130 is 150. So angle 7 has to be 30 to give me a total of 180. And let's see what else we have here. Okay, angle 4. If you look right here, students, I have a straight line. Okay, look carefully, a straight line. And a straight line always has an angle measurement of 180. I have three angles that are coming off the straight line. 125, angle 4, and 25. So all three of those have to add up to 180. So 125 plus 25 is 150. So angle 4 has to be 30 degrees. Now if angle 4 is 30 degrees, I have a triangle right here. Look, here's my triangle. Right there, okay? And so I have two angles of 30 and 125. That's 155. So this has to be 25 degrees right here, okay? Now, let's see what else we have. Okay, I'm trying to correct my last two angles, 8 and 9, okay? If you'll look, they're both inside this triangle here. And I know this angle here is 90. So watch what I do. This is so cool. Watch this, guys. Here's a line, and here's a line. See that? They're intersecting. That means, now watch, that means this whole angle here is congruent to this whole angle here. You say, well, Mr. Arrow, we don't know this angle right here. This big angle. Yeah, we do, guys. Look. This big angle right here is made up of two angles, 25 degrees, one dot, and 25 degrees, one dot. So this whole angle is 50 right here. So if that whole angle is 50, this angle over here is 52. So angle 8 is 50. Then you have 50 plus 90 is 140. So angle 9 has to be 40 to give you 180. Okay, these are pretty fun as long as you just take your time and work your way through them. All right, the directions for 23 through 26 say to draw and label a right triangle, and make sure the right angle is angle C. Okay. So here we go. Here's my right triangle. This is angle C. We'll call it A, C, and then B. Okay. So here we go. We're going to use this triangle here over and over. Let me copy it real quick, and we'll use it over and over. And here we go. All right. So this is 90 right here, and angle A is 13. So 90 plus 13 is 103. This has to be 77 degrees. Okay, pretty simple. And there's the answer. All right, moving on. 90 degrees, angle A is 47. So this has to be 43 degrees. Because 43 plus 47 is 90, and 90 plus 90 is 180. Okay, moving on to number 25. Let's see what we have here. This is 90. Angle A is 28. This would have to be 62 because 62 plus 28 is 90, and 90 plus 90 is 180. Number 26. And here we go. This is 90. Angle A is 53. So this would have to be 37 because 37 plus 53 is 90, and 90 plus 90 is 180. Okay, students. Moving on to number 20 or 31. Here we go. Now, if you look in the directions, they already said something. The directions say that if you look at the directions, it says that this little triangle here and this little triangle here and this little triangle here are all congruent. They already told us. If you read the directions, you'll see that it says the little triangles are congruent. So, how do we know that the big triangle A, B, C, see, how do we know that big triangle's equilateral? Think about it, guys. Very easy. I'll tell you why. Because if I'm going to type this at the same time, watch carefully, okay? If the smaller triangles are congruent, which they are, then segments AB, BC, and AC have to be congruent. How do I know that, students? Think about it, guys. We learned that we've learned that when triangles are congruent, then all of their parts are congruent. So if I know that triangle number 1 is congruent to triangle number 2, and triangle number 2 is congruent to triangle number 3, and triangle number 3 is congruent to triangle number 1, then I know this side here has to be congruent to this side here, has to be congruent to this side here, because remember, the definition of congruent triangles is all 6 parts of each triangle are congruent. So if I know then that these segments are congruent, then I can definitely state that ABC is an equilateral, because an equilateral triangle has all 3 sides congruent, and I know that this side here is congruent to this side here, is congruent to this side here. Okay, I hope that makes sense. That would be the reason why. Okay, all right, moving on to number 32. Each of the smaller triangles have congruent angles. Find the measure of, now look carefully, find the measure of DBC. So here's D, here's B, here's C, so this angle here. And then find the measure of DCB. So D, then C, then B, this angle here. Well, students, think about it. We already know that this angle here has to be congruent to this angle here, has to be congruent to this angle here, because all 3 triangles are congruent. Now think about that for a second, guys. Come on. Think about this. Remember when someone in a basketball game jumps and dunks a basketball, and he jumps in the air, and he does a complete circle, and then he dunks the basketball, okay? Well, we call that a 360 dunk, and the reason we call it that is because the guy went a complete circle. Well, look, I'm going in a complete circle. If I start here and go all the way around, that's 360 degrees. So I'm taking 360 degrees and I'm dividing up into 3 angles. Angle number 1, angle number 2, and angle number 3. So 360 divided by 3 is 120. So this angle right here is 120 degrees. This angle is 120 degrees, and this angle is 120. Now, if these 2 angles here are congruent, and it says they are, look, it says each of the smaller triangles has 2, look right here, congruent angles. So if this angle here is 120, take 180 minus 120. Now why 180? Because in this triangle, all 3 of your interior angles have to add up to what? 180. So this is 120. I'm going to take 180 and subtract 120. I get 60. Well, that means if these 2 little angles here are congruent, each of them has to be 30 degrees, right? So 30, 30. So that's why the answer is 30, okay? All right, find the measure of CDB. We already did that. We already did that, guys, right here, look. Find the measure of CDB, this angle right here. We already did that. It's 120 degrees, okay? I explain why ABC is equiangular. Well, sure, guys. Look, okay, watch this. Now, look. How do I know that triangle ABC is equiangular? Well, look. What did I just state that? Hold on one second. What did I just state? This angle right here is 30. And what is this angle here? 30. Well, earlier we talked about how all 3 triangles are congruent. This triangle here, this triangle here, and this triangle here, all congruent. So if they're all congruent, that means this angle right here is also 30. Well, 30 plus 30 gives you an angle of 60. This angle is 30, and this angle here is 30, so the whole angle is 60. And this angle here is 30, so the whole angle is 60. So how would you explain it? I would explain it like this. I would say this. I would say because each angle of triangle ABC is divided up into two angles of 30 degrees. Thus, each angle of triangle ABC has to be 60 degrees. That's how I would word that, okay? All right, moving on to numbers 35, or number 35. Okay, students, let's prove a theorem here. I want to do a really good job. I'm going to go fast, so you'll probably have to pause the video a lot, but do understand that you can pause the video, so I'm going to go really fast here, okay? If two angles of one triangle are congruent to two angles of a second triangle, then their third angles are congruent. Okay, the first thing you do is you draw your picture, okay? Wow, it's a really good triangle, isn't it? Okay, so here we go. Here's my first triangle, and here's my second triangle, okay? Good enough, close enough, okay? We're going to call these angles 1, 2, and 3, 4, 5, and 6. Got it? Okay, there's my triangles. Now, here's my given. Now let's stop. You see what I'm doing? Whenever I ask you to prove a theorem, you first of all draw your figures, okay? And second of all, you then put your given. Now your if is your given. If two angles in one triangle are congruent to two angles in a second, so I'm going to state that angle 1 is congruent to angle 4 and angle 2 is congruent to angle 5. That's my given, okay? Then the third angles are congruent. Well, your then part's your proof, so you're proving that angle 3 is congruent to angle 6. Now, hopefully you understand this, okay? Your if part is your given. Your then part is your proof. So anytime I ask you to prove a theorem, you draw your figure, and you list your given, then you list your proof. Now we're going to brainstorm, okay? Now here's how we're going to do this. We're going to use the interior angles equaling 180. We're going to use that to help us. Okay, so here we go. I'm going to brainstorm over here. So here we go. 1 plus 2 plus 3 equals 180. This is going to be pretty easy, guys. 4 plus 5 plus 6 equals 180. And now what can I substitute? For 1, I can substitute 4, so I can put a 4 here. And for 2, I can put 5. There we go. Okay? So, now let's see here. What I would probably do next is I would subtract angle 4. I'd bring angle 4 over here and make it negative. Bring angle 5 over here and make it negative. Remember, guys, I'm just brainstorming, okay? That would bring angle 4 over here and make it negative. Bring angle 5 over here and make it negative. Look what I'm left with. Angle 3 equals this. Angle 6 equals this. I can use substitution. I can put 6 in for this, and I can see that angle 3 equals angle 6. So, I've got a pretty good plan of attack here. So here's what I'm going to do. Here we go. I'm going to start off with my statements and my reasons. Okay, so here we go. Okay, number 1, you would list out your given. So angle 1 is congruent to angle 4. I'm going to go really fast here. I'm not going to try to be neat, students, okay? Angle 2 is congruent to angle 5, and that would be your given, okay? All right, angle 2, or step 2, I would say that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180. I would also say in the same step the measure of angle 4 plus the measure of angle 5 plus the measure of angle 6 equals 180. Now I'm allowed to state that because we have a theorem that says interior, and look how I abbreviate this, guys. You don't have to be perfect, okay? As long as you give a valid reason over here, you're fine. Okay, so interior angles of a triangle equal 180. There we go. Now, be careful. Stop, students. Listen. You cannot make a substitution. Yet you cannot substitute 1 in for 4 down here or 2 in for 5 or whatever, because you can never substitute when you have congruent symbols. Okay, now I have equal signs here, but you cannot use substitution unless you have equal signs. So what I have to do is I have to take my step 1 here, and I'm going to convert it over to equal signs, okay? So I'm going to say the measure of angle 1 equals the measure of angle 4. I know that's kind of dumb, but it's how geometry is, okay? So if 1 is congruent to 4, then if 1 is congruent to 4, then 1 equals 4. And if 2 is congruent to 5, then 2 equals 5. Now, what reason would you use? Well, you have to say definition of congruent angles, because the definition is when two angles are congruent, they have the same measure, okay? So we're good there. Now I can make substitutions. So see right here I have, I'm going to put, for step 4, I'm going to put for measure of angle 1, I'm going to put a 4. So measure of angle 4 plus, for angle 2 right here, I'm going to put a 5. Measure of angle 5 plus measure of angle 3 equals 180. Now, my reason, of course, is substitution. Now, beneath this, I'm going to go ahead and write my other equations. So they're right on top of each other. So now I have this. I have the measure of angle 4 plus the measure of angle 5. Now you're like, well, Mr. Earhart, why are you putting that there? You didn't really do any substitution on this one right here. I know I did. Now, you don't have to do that if you don't want to. I'm just doing it so that I can have the two equations on top of each other and kind of compare them a little easier, okay? That's my reason why. So either way is fine. Now, hopefully you've taken good notes. I'm going to erase all this and give myself some room here. Okay, now for step 5, look what I would do for step 5, okay? I would write the measure of angle 3 equals 180 minus the measure of angle 4 minus the measure of angle 5, okay? And then I'd put the measure of angle 6 equals 180 minus the measure of angle 4 minus the measure of angle 5. And the reason, of course, would be subtraction, okay? And then you can do substitution. The measure of angle 6 equals this. So you can pick it up and put it into this right here. So now you have the measure of angle 3 equals the measure of angle 6. Okay? And that would be substitution. And then you're finally done. Remember, you were trying to prove they're congruent, so they're equal. And once you state that, these two angles here are equal, you can state they're congruent. So the measure of angle 3 is congruent to the measure of angle 6. And of course, the reason would be, again, definition of congruent angles. Okay? All right, that's theorem 3.5. Let's take a look at theorem 3.6. The acute angles of a right triangle are complementary. We're probably going to do it the exact same way, I would think, but here we go. Let's get our picture drawn here. We have a triangle. Okay? It's a right triangle, and we're going to call this angle 1 and angle 2. I guess we'll call this angle 3, okay? So there we go. So we're given our if part would be if we have a right triangle, then the acute angles are complementary, okay? So that's what we're given. So if we have a right triangle, and I'm just taking this theorem right here, students, and I'm writing it if then form. If we have a right triangle, then the acute angles are what? Complementary, okay? So here we go. If I'm given, let's call this ABC. I'm given triangle ABC and acute angles 1 and 2. So I'm going to prove that angles 1 and 2 are what? Complementary. Now it's pretty obvious how I'm going to do this. Somehow students will have to state that 1 plus 2 equals 90. Shouldn't it be easy to do, guys? Look, I'm just going to brainstorm here. Could I not easily state, can I not easily state that angle 1 plus angle 2 plus angle 3 equals 180, right? And I can substitute 90 for 3. And then subtract 90 from both sides, and I would have this. So it's pretty simple proof, okay? Really is. So with that in mind, here's my statements, here's my reasons, and here we go. So I have my given triangle A, B, C, and acute angles 1 and 2, and it's my given. Okay, now, next, I'm going to state that the measure of angle 3 equals what? 90 degrees. How can I state that? Well, definition of a right triangle. Okay, definition of a right triangle. Think about it. Look at my given. I'm given that I have a what? A right triangle. So by definition, the definition of a right triangle is one angle is 90 degrees. So angle 3 equals 90 degrees. Definition of a right triangle. Now, I'm also going to go ahead and put this. Angle 1, measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180. And that's because interior angles of triangle equal 180. Okay, now I can make a substitution. Look right here, the measure of angle 3 equals 90, so I can put the measure of angle 1 plus the measure of angle 2 plus 90 degrees equals 180, and that would be called substitution. Okay, because I substituted 90 for angle 3. Now watch, subtract 90 from both sides. Okay, if you subtract 90 from both sides, you're left with the measure of angle 1 plus the measure of angle 2 equals 90. That's subtraction property. Okay, and now you're good. Look what you just said. You just said 1 plus 2 is 90. So now you can say that angles 1 and 2 are what? Complementary. And how can you say that? Well, definition of complementary angles. The definition of complementary angles is their sum is 90, and you just stated here their sum is 90, so we can definitely state that they're complementary. Okay, not too bad, really, guys. Not too bad of proofs. Okay, all right, moving on to 37, 38, and 39. Now on these, this is really algebra. Algebra 1, guys. It's really simple. You know that all three angles have to add up to 180. So really, I have x plus 30 plus x plus 60. So I take this angle plus this angle plus this angle. They add up to 180. So x plus x plus x is 3x. And 30 plus 60. Well, I shouldn't put an equal sign. 30 plus 60 would be 90. Now subtract 90 from both sides and you're left with 3x equals 90. Okay, and divide by 3 and x equals 30. So now we'll quickly find each angle like they want us to do. X equals 30. So this angle here is 30. X is 30, so 30 plus 30 is 60. So this angle here has to be 90. There we go. Okay, number 38, here we go. Well, same thing. We're going to take x plus this angle here, x plus 25 plus this angle here, and when you add all three angles together, you get 180. Now x plus x plus x is 3x. 25 minus 25 is 0. They cancel out. So 3x equals 180. Divide both sides by 3. And x equals 60. So here we go. This would be 60. X is 60. So 60 plus 25 would be 85. And then 60 minus 25 would be 45 degrees. No, not at all. 35 degrees. Sorry about that. Be 35 degrees. And there we go. There's your three angles, okay? All right, number 39, we have 3x plus 2 plus 6x plus 11 plus 5x minus 1 equals 180. So here we go. 3x, 6x, and 5x would be 14x. And 2 plus 11 is 13 minus 1 is 12. So we simplified our left side. Now subtract 12 from both sides. Or what I like to do is I say this, bring the 12 over and make it negative. Bring it over and make it negative, and you're left with 14x equals 168. Okay, 168. Now, 14 goes into 168 12 times. So x equals 12. Okay, so if you put 12 in for x here, you get 38 degrees. If you put 12 into x here, you would get 59 degrees, I believe. Yes, 59. And then if you put 12 in for x here, you would get 83 degrees. Okay, now if I'm going too fast, don't hesitate to pause the video and back it up and watch it again, okay? That's one of the benefits of having a video class, all right? So if I'm going too fast, back it up and watch it again, okay? Okay, number 40, here we go. Okay, we have 3x minus 10 plus 2x plus 110 minus x equals 180. Now watch this carefully, okay? 3x plus 2x is 5x minus 1x is 4x. Then we have negative 10 and positive 110, that's positive 100, equals 180. Now bring the 100 over and make it a negative 100. And that will leave you with 4x equals 80, okay? Now divide both sides by 4 and x equals 20. So if x equals 20, this is pretty simple. 2 times 20 is 40 degrees. 60 minus 10 is 50 degrees. And 100 minus 20 is 90 degrees. So there you go. 50, 90, and 40, okay? So all four of those were done pretty much the same way, okay? Pretty much the same way. Number 41 through 44, here we go. This will be good. We're going to apply a little bit of percentage and a little bit of fractions to angles here. This will be good for us, okay? Number 41, of the 400 people polled, 88 had children who woke up with an alarm clock. Now what we're going to do here, I should have first read the direction, okay? Decide whether the statement comes from the given data. In other words, we're going to read each one of these statements and say to ourselves, can we really make these statements? Okay, can we do that? So let's see, students, if these statements here can be figured out from this diagram over here. Okay, of the 400 people polled, 88 children woke up with an alarm clock. Well, let's see if that's true. 22% wake up with an alarm clock, correct? So 400 people were polled. So remember what to do from hopefully middle school math. You take your total times your percent, and what you would give, use a calculator and type this in, you will get 88, trust me. So yes for number 41, put check mark here. Yes, we do get this information here from the chart over here. Definitely, yes, we do. Okay, no problem there. All right. Number 42, over half do not call their children to wake up. Let's see, how many do not call their children to wake up? Well, let's see, 43% call their children to wake them up, okay? Now, now, if 43 call their children, that means 100% minus 43. That means 57% do not call their children to wake them up. And look what it says. Over half do not call their children. That's true, yes, right here I just showed you. 43% call their children. So 57% do not. Okay, do not. So there we go. Yes, you can definitely make this statement based on the diagram over here, definitely. Okay, number 43, each respondent to the poll is accounted for only once in the circle graph. Yes, definitely. That's totally true. And I mean, the way I know that is you cannot give a kid an alarm clock and he wakes up that way and he also wakes up by you calling him. Or you can't say that you call your kids to wake them up and at the same time they wake themselves up. There's no overlapping methods here, okay? They're all different. So yes, each person that you polled is accounted for only once in the graph. Yes, that's true. Okay, more than 4/5 of the people surveyed had children who did not wake up on their own. Did not. Okay, now, let's see. 16% wake up on their own, correct? See that? Got it? So, if 16% wake up on their own without any help at all, that means 84% do not wake up on their own. Okay, do not. Now, let's see if that matches this. More than 4/5. We'll hold it. 4/5. Well, let's change that to a percentage. Let's change that to a percentage real quick, okay? If you take a calculator and type in 4 divided by 5, you're going to get 0.8. Because remember, a fraction is a division problem. 4/5 is 4 divided by 5. So if you take a calculator and type in 4 divided by 5, you will get 0.8. Well, if you take 0.8 and change that to a percentage, you will get 80%. So when they say 4/5, we could really put, instead of 4/5, we could really put what? 80%. So let's reread this and see if it's true. More than 80% of the people surveyed do not wake, their children do not wake up on their own. Is that true? Yes, because I just showed you down here that 84% do not wake up on their own. So if 84% do not wake up on their own, and it says more than 80% do not wake up on their own, yes, it's totally true, and yes, we can definitely state that. We can definitely state that based on the information given to us over here. So all of these were a big yes. Okay, we can definitely state them. Okay. All right. I hope this homework video has been a help to you guys. If you have any questions, don't hesitate to call or email.